Alright, this problem is pretty complicated, so brace yourself. And before we get started, let me show you the chart. Pause the video and copy this chart down. Keep this chart with you at all times throughout this unit. Certainly, if you're taking a quiz or a test, you're going to want to have this chart by your side. These are all the variations on the Pythagorean identity. Okay, so sine squared theta plus cosine squared theta equals 1. That is the Pythagorean identity. But all of these other equations, all of these other identities sort of flow from that. But just copy this down and use it. So look at this one right here. 1 plus tangent squared theta equals secant squared theta. We're going to wind up using that one in this problem, I can tell, because I see secant squared right there. So, in fact, when I look and I see tangent and secant all over the place, that draws my attention to this box right here, and I start doing stuff. Okay, so this is going to be complicated. So, first of all, I'm going to make that little substitution that I just told you. So, secant squared is 1 plus tangent squared. Alright, so this equation is going to become tangent to the third power minus 1 over tangent theta minus 1 minus, now I'm going to have to put this in parentheses because I have a binomial coming. And so when I have a minus sign, this minus sign has to apply to the whole binomial. 1 plus tangent squared theta. Got to use parentheses. A common mistake is not putting parentheses, but you will get the wrong answer. So now I'm just picking up where I left off. Plus 1 is equal to 0. Okay, so because of the parentheses, now I can see that I have to distribute this minus sign. Okay, so I don't think I feel like rewriting the entire thing. So if I distribute the minus sign, it'll be minus 1 and then minus tangent. So I think I'm just going to fake it. Okay, see there, I distributed the minus sign. You saw it happen. Okay, but now look what I got right here going on. I have a minus 1 and I have a plus 1. Those are opposites. Those are going to cancel each other out. So once they cancel each other out, then now I have tangent cubed theta minus 1 over tangent theta minus 1 minus tangent squared theta is equal to 0. Okay? Now, again, there's probably more than one way to solve this problem. In fact, let me think. Do I want to make like denominators with this? Or do I want to move this over to the other side and multiply? Okay, maybe I'll go for the like denominator method. That's not what I thought I was going to do, but now that I'm here, when you have a fraction and something else, it's very often a good thing to do to make like denominators and put them together. So let's try that and see what happens. Alright, I'm going to need a little bit more space. So I'm going to move that equals 0 over a little bit. So here come like denominators. I can put the like denominator of tangent theta minus 1 down here, as long as I put the same thing in the numerator, tangent theta minus 1. Okay, so now I need to bring this up, make some space for it, and I need to multiply this out. Okay, so here we go. I'm going to have tangent cubed theta minus 1 over tangent theta minus 1 minus, and then up in the numerator here, I'm going to have to distribute this. So I'm going to have, what am I going to have? I'm going to have tangent cubed theta, alright, tangent squared times tangent is tangent cubed, minus, now tangent squared times 1 is tangent squared, so minus tangent squared theta. And that's all over my like denominator of tangent theta minus 1. Now the whole point of making like denominators is putting these together into 1. Now be careful though, when I combine these, I need to put parentheses again around this binomial. So now I'm going to have tangent cube theta minus 1 minus, in parentheses, tangent cube theta minus tangent squared theta. I almost forgot the equal 0. Let's not forget that. Equals 0. Tangent squared theta. And now I'm putting this all over my like denominator, over tangent theta minus 1 is equal to 0. Okay, this is great. So now I'm going to distribute this minus sign. And again, I don't really feel like recopying this whole thing just to distribute the minus sign. So this will wind up being minus tangent and then a plus tangent squared. So I'm just going to go ahead and do that. But again, a really common mistake is not putting parentheses and just leaving this minus a minus when it should distribute and become a plus. Alright, that's probably the most common mistake. Okay. Now, look what's happening in the numerator. Again, I have these like terms. I have tangent cubed theta, and then I have minus tangent cubed theta. Well, those are just going to cancel each other right out. Okay, so those are gone. So that leaves me with negative 1 plus tangent squared theta. I think it would be more fun to write that as tangent squared theta minus 1, though. Alright, so I'm going to do that. And then that is over tangent theta minus 1. And all this equals 0. Okay, so this is really, really different than anything I thought I was going to do when I started this problem. Alright, in fact, I solved this whole problem a completely different way earlier. Because difference of squares is what I'm seeing right now, is really what you want to do at this point. What do I mean by that? If I have a squared minus b squared, that's the difference of squares. That could be factored as a plus b times a minus b, right? Well, that's the same thing we have here. In fact, here, let me make it even more obvious. Say if I had a, instead of a squared minus b squared, say if I had a squared minus 9. Would you agree? Oh man, a and 9, those look too much the same. Let me not use a. Let's say I had x squared minus 9. You would agree that this would be x plus 3 times x minus 3, right? Okay. Now, what if instead of a 9, this was a 1? X squared minus 1. Well, this is a perfect square just like 9 is. So this is still the difference of squares. This would be x plus 1 times x minus 1. Okay, that's the same situation that we have here. Instead of x squared minus 1, we have tangent squared minus 1. But it is still the difference of squares. So just like a minute ago I showed you x plus 1, x minus 1, this numerator will factor as tangent theta plus 1 times tangent theta minus 1. Okay, And oh look what we have in the denominator. Tangent theta minus 1. All that is equal to 0. Okay, why am I so excited about this? Well, we have the same thing in the numerator and the denominator. So these are going to cancel each other out. Those are gone now. So that's going to leave us with tangent theta plus 1 is equal to 0. And then subtracting 1 from both sides, that will give us tangent theta is equal to negative 1. Okay, now, so I really solved this as far as I can. Time to look back and see what we were supposed to be finding. We're supposed to find cotangent theta. Well, cotangent is just the reciprocal of tangent. Alright, so if tangent is equal to 1, then cotangent will equal the reciprocal of 1. What is the reciprocal? The reciprocal of negative 1. The reciprocal of something is just what you get if you put a 1 over it. But 1 divided by negative 1 is still negative 1. So the reciprocal of negative 1 is itself. So cotangent theta will equal negative 1 as well. So that is the answer. So let's just look back at our choices and verify that we got it. Okay, so the choice, the answer is A, which is in fact negative 1.